Welcome, this is a 3.5 Ready Set Go homework solution. Here we have the ready part. It says for each function find the indicated value, and it looks like it's asking us, we're given the function of h here and we are asked to find -4, right? So I plug in -4 in for t, because again you see how t is replaced by -4. So t here is substitute with -4. 2 times -4 times -5 is -13. B, okay? This time they say h of t equals to 23. H of t is equal to 23. So I made that substitution. H of t becomes 23, and I solve for t in this case. Okay? So I add the 5 to both sides, then divide by 2. T gets me 14. See? Here I'm seeing what happens when I have t is equal to 13, right? Okay. Sorry, that should be 13. Okay, and the answer is 21, because this becomes 26 minus 5 is 21. Okay, this one looks like it's asking me to solve for t, given that h of t is equal to -3. -33. Set up the equation, solve for t. Right? Add 5 to both sides, then divide by 2. Get you the t here. Okay? This is how it looks like when it looks like just giving us in terms of an equation. Here we're giving it in terms of a graph. Right? It says g of 2, right, equals. What does this mean? It says given the input, because the what goes in that parentheses is the input. Okay? Given the input is 2, the output is 9. Do you want to see that? I could just bring up Paint if you need to see that. Okay? Hold on. I need to paste it over and make sure. Okay, so give me a second. Okay. Alright. So when we have the image, we can play with it in Paint. So, alright. So, the input is 2, so let's look at that. 1, 2. So this is x equals 2. That's the input. X is equal to 2. That's the input. Let's see if that works. Goes all the way up. And that does hit 9. Right, that does hit 9. So the output here is 9. Output is 9. There you go. When is g of x equal to 3? Okay, again, we could bring up Paint for that. We're seeing when is that output equal to 3. So we are looking for output is equal to 3. Okay, where is that? So let's draw the arrow. 1, 2, 3. That is when the output is equal to 3. When is that? That looks like, sorry. Okay, that looks like when x is equal to 1. So x is equal to 1. Right? X is equal to 1. There you go. Right? So the output here is 3 when the input here is 1. Right? Last one, when the input is 0, the output is 1. Okay? That's how we use that graph. D, what happens when we are giving it in a chart? Okay, I saw this grows exponentially. I have the 0 term, so I use the 0 term equation. The g of 0 is 1. The common ratio is 3. Plug it in. Alright, let's look at this one. Same process as before. I saw that do you want to see this one? Here, let me do this one. Okay. I won't do it for all the problems, but I want to make sure you at least see one of the linears. Okay. Alright. Okay. Alright, let's look at this. Alright, it says the input is -1. Where is that? So -1. -1's here. Is that the input? Is that the input though? Yeah, the input's -1. So this is where -1 is. Alright, yep, it looks like the height. So when the input is -1, okay, the output is right there. It looks like it is at 10. Output is at 10. And did I get that answer? Yep. What happens when the output is 4? So we're gonna look like output. That's the output 4. That is the output of 4. Let's see. Let's look at the input right there. Looks like the input here is at 1. So the input is 1 at that point. Good. What is the 0, 1? The 0 when f, it looks like that is the y-intercept, so that's why we could do that one. What is r of 0? The r is 0. The r of 0 is referred to the input is 0. So this is when the input is 0. Okay, that is the input of 0. Alright, let's see what the output is. Output looks like that is 7. Right? Yep, there you go. Right? Because it's linear, I can use y equals mx plus b. I have the b term there. Very straightforward. Okay. Here, if you want to pause the video to see the solution for that one. Okay. Here's the set part. Two function or graph. Graph a new function on the same grid by adding the two functions. Okay. Alright. So here, some of you might not find it difficult. The way I did it is I actually had a graph grab each point, write it in y equals mx plus b, then graph it on decimals. So let me show it to you, okay? So the first one, I saw that the intercept was 0 and its slope was -1. So f of x is equal to -1x plus 0, right? I just had to look at it. The next one, I saw that it was a 1/2 slope and the y-intercept was 2. Okay, that was g of x. Okay, now to graph it, I just combined so I could define a new one. So I'm going to say this is h of x is going to be my f of x plus my g of x. Okay. Do you see how decimals does it automatically for you? Notice that the y-intercept here is added and the slope, right, is in between. It averages out. Okay, so that is how you would graph it. Okay, next, same process as before. This was a little bit weird because when you take algebra 2, you're most likely going to be given those equations, then you could graph it, okay? Right? So that's how the solutions really are. They just want to introduce to you the idea of composite functions, okay? Alright. Next, let's take a look at this part. Using the graph to answer the following equations. Where does f of x equals to g of x? That is its intersection here, right? The point that they intersect, and that looks like it is at 2, 5. That is correct. What is f of 4 plus g of 4? So f of 4 looks like it is at 6, and no, that's g of 4. It looks like it's at 6, and it looks like it is at 7 for f of 4. So together, it's roughly around 13, right? Because I had to do an approximation. I had an estimate. That's why I used this wiggly sign. It's approximately 13. What about negative g of negative 2 minus f of negative 2? So I have to, this is where the negative 2's are, right? So g of negative 2 looks like it is at a 1. F of negative 2 looks like it is at around 3. You're, right? And then you want to do the subtraction, so that it is approximately 3 minus 1. So the answer would be approximately around 2. Right? D, state the interval where g of x is greater than f of x. So f of x here is big at this point. So it goes from, because here it's weird. I think it goes on forever. So that's why I treat it as infinity. Okay? And it goes all the way to 2. Right? Then it switches. So I would say it goes from negative infinity to 2. Okay? That would be the interval. Right? Here, if you want to like to see it. Alright, so I would say that it is from negative infinity all the way to 2, and it looks like it alright, I could open it at 2. Okay, that's how it is. Alright, open at negative 2 and negative infinity, and also S2 as well. Okay, alright, let's look at the other one. Let's look at 6. Right? Where's r of x greater than h of x? Right? So here, all this part here, r of x is still ahead. So it starts all the way here from negative infinity all the way until this point here, and I'm going to treat that as 2.3 approximately. So I would say it is open at negative infinity, goes all the way to 2.3, and it is still open there. What is r of 1 minus h of 1? I have r of 1 is around, what, 0.5, and h of 1 is around 0.2, right? So if you do your subtraction, it is 0.3. H of 0, so h of 0 was 0.2. R of 0 was 1, so 1 minus 0.2 is 0.8. Write the explicit rule for r of x and h of x. Here you go. Okay. This is just flat. There's no rate, so h of x is just always equal to 0.2. R of x is a decline. R of x is a decline, so that's why it's 1/2 to the x. Okay. Next, it says sketch how r of x minus h of x looks like. In reality, there's a better way of answering this, right? Even in Desmos, you can just graph it, right? You want me to show it to you in Desmos? Alright, let's bring it up in Desmos. Okay. Alright. Here, I'm going to define r of x as 1 divided by 2 to close, and that's to the x. Okay. The next one, I will say it is a 0.2. It should be a straight line. Right? Oh, sorry. Just want to zoom this in. You see? See? Right? Then you want to do r of x minus h of x, right? So, zoom out a little bit. Alright, let's do a RHI, so I can go J. J of x is going to be equal to R minus H, so R minus H of x. So do you see how it goes in between? Right? There you go. Right? And that would be your ready part. So let's look at your go part now. For each contact of the representation, determine whether it is discrete or continuous, or it could be modeled best in a discrete or continuous way. Justify. 8. Susan puts $5 a week in a piggy bank. The week here, the domain is week. The week is a time, so that is continuous. That range of exactly $5. Again, money is discrete, so I would say based on the domain, it would be continuous. Okay, but based on the dollar amount, it would be discrete. Right, 9. This is just a discrete graph because of the dot, so I would say it's discrete. The graph contains only points, and it's not a continuous line. 10. It's a continuous line, so I would say it's continuous. 11. Marshall tracks the number of hits he gets each baseball game. Hits are a finite thing. You cannot get 1.5 of hit, so it would be discrete. The distance you travel since the day began. Distance is continuous because you could always have 1.5 miles. Okay, so that would be is continuous, so it's continuous. Next, gumball. Gumball is discrete because you can't have 1.5 gunballs, right? Next, Stefan deposits $1,000 in a savings account at his bank. When he turns 21, his deposit is $100 each month, right? So again, month is continuous, but money is discrete. So it depends if you want to look at the domain and range. In this sense, I would treat it as something that is continuous. Okay? Alright, there you go. Those are all your homework solutions for 3.5.